Hi there, friends. My name is Peregrine from the Museum of Life and Science. I'm here with Catalyst volunteer Caroline, who is going to be moderating in the chat today. Welcome to the very first Lab at Your Library program. Now, I know it's not officially at the library, but the library was a huge part of making this program possible. Thank you so much to our Durham libraries for passing out the kits that are required for doing this program and getting science supplies into the hands of all of you wonderful viewers and participants. So Lab at Your Library is a spin-off of some of our other virtual programs, such as Lab at Home, like this one, and Little Lab at Home, which have a similar feel. The idea behind Lab and Little Lab at Home is that we ask you guys to bring your own materials. Lab at Your Library is different because we had you guys pick up a kit, and this has almost all of the materials that you need to participate. And I'll tell you a little bit about the materials that are in your kit. So in your kit, you should have a cup. Taped to that cup is a little LED. I think yours should be a slightly bigger version of this one. But if there is an LED, it should be taped to your cup. Go ahead and take that off right now. Just carefully kind of peel the tape off so that you can detach your LED. You should have two golf pencils, two little pencils. You should have a pencil sharpener like this. You should have a 9-volt battery, a little bag of this kind of white crystal looking stuff. This is Epsom salt. I'll talk about what it's for in a minute. You should also have a little square of foam. I don't know if we mentioned our popsicle stick yet, but you should have a craft stick. This is going to be for stirring. And we should have two sets of alligator clip wires. So this is everything that was included in your kit. And there's one more thing I want to ask you to get. For our experiment, we need some water, just regular water from the tap, but we need enough water to fill to this line right here. So we want to fill it about 2/3 full. So I'm going to take some water that I have right here, and I'm going to fill my cup up 2/3 full. And I know that we could not include the water in the kit. Everything would get all soggy. We especially don't want water and battery mixing. So I'm going to give you all a chance here to grab some water, and you want to fill your cup about 2/3 full. Let's talk a little bit about what today's experiment is. Now, we've gone over the supplies that we have, right? We may not know what like the Epsom salt is for, we may not be totally sure what the foam board is for, but if you see stuff like a battery and some wires and some LEDs, what do you think we're going to be talking about today? What do you think we might be experimenting with? Any ideas? You can let me know in the chat. I'd love to hear from you guys. What are your ideas for what we might be doing? It's okay if we don't know exactly, but what comes to mind when we're looking at stuff like batteries and wires? We have a couple friends saying, oh yeah, electricity. We have a friend saying energy. Ooh, I have a friend who says making electrons move. Oh yeah, oh, you guys are exactly right. We have a lot of friends who are guessing electricity. Exactly. We are going to be doing an experiment that involves electricity. And I wanted to talk first about what electricity is. So electricity is really important. We're using it right now to talk to each other through the computer. Electricity is what happens when particles move. And when we're thinking about particles, we're thinking about all of the materials in our world are made up of teeny tiny little pieces. Almost like if you build something out of Legos. So everything is made out of these teeny tiny pieces called atoms, and those atoms make up molecules, and they're kind of like Legos. Every atom has little pieces that make it what it is, and those pieces are called particles. So each of these Legos represents a particle. Electricity is what happens if we have a whole line of certain kinds of atoms or certain kinds of Legos, and they're passing particles along. It's almost like a big line of catch. Like someone has a ball, they're throwing it to someone else, who's throwing it to the next person, who's throwing it to the next person, who's throwing it to the person after that. That energy is electrical. energy. So passing particles on, or passing Lego pieces on. And what does electricity do, or what can we do with electrical energy? Is there something that you've done today with electrical energy? Oh, I have a friend saying something you can do with electrical energy is get shocked, is to shock yourself. Yes, that's a good point. And that brings us to a very important point about battery safety. We'll talk about that in a second. Oh, my friend is also saying Zoom is something that you do with electricity. Yes, this Zoom meeting is made possible by electrical energy. Oh, you can make light. Oh, this is perfect. You can watch TV, right? Sometimes our heating for our water is electric sometimes. Oh, you can charge something like an electrical device, like a phone or a computer. There are so many things that electrical energy does for us. And one of my friends mentioned making light. Now, you all have a little LED light. And we know that to make this light light up, it needs a power source. So your power source, by the way, is gonna be your 9-volt, but big warning here, we're not going to be connecting our 9-volt directly to our LED. The reason is because if we connected these directly, you would do what I did earlier, which was burn out my LED. This battery has so much voltage, so much energy that it will burn out your LED. So while we will be making this light up, we don't want to touch this directly to our battery. We have our power source, we have a light source, and we're going to be talking about how to light up this light source and how to do something else with electrical energy. I have a different kind of battery here. This is one that just I have, called a coin battery, and that's how we know that this one works. This one lights up. A battery works when you connect one end of your device to the battery and then a different end to the battery, because electricity flows in something called a circuit. A circuit is the flow that these particles have to flow in. So we're saying that something that electricity can do is make lights. It has to go through a certain path, and in order to go through that path, it needs certain materials. So electricity can't move through everything, right? So something that electricity can't really move through is something like rubber, right? If I were to put a piece of rubber between my battery and my LED, it wouldn't be able to light up. The flow of those electrons would be blocked. So we want to find something that electricity can move through. Do you guys have any ideas about what sorts of things electricity can move through? Give me some ideas in the chat. Some things that are what we would call a good conductor, something that electricity can move through really well. Ooh, the wire, I love it. So wire is something that's really good. Now the metal of these wires is particularly good, and they're surrounded by some of this kind of like flexible plastic stuff, which is good at keeping the electricity going through the wires and not going anywhere else. This is a great point. My friend was saying wood, not a very good conductor. You're right, not very good at moving those electrons around. Oh, I have a friend who's saying copper. Copper is a great example of a conductive metal. And I have a friend who says water. Now, this is really interesting. I don't know about you guys, but I've always heard that you should not go swimming when there is a thunderstorm, because there's a chance that your body could be shocked by electricity if there was a lightning strike on that water. And I always wondered about that. And it's not the water itself that conducts electricity, it's the fact that we are in it and we're contributing something to the water. The reason that electricity can move through water that we're swimming in and potentially harm us, and the reason why our bodies can move electricity around, right? Because our brains use electricity to send signals to our body. It needs liquid, it does need water, and it needs something else. It needs salt. So when we talk about stuff like, I don't know if you've ever heard about like electrolytes and stuff like that, stuff that's, it's good to keep yourself hydrated so that your brain can send good signals to your body, you need electrolytes. And salt is one example of an electrolyte. So all of you have a form of salt right here, and this is a different form of salt. It's a like magnesium salt instead of normal table salt. And we'll talk about the reason why. But this salt is what's going to make our water a good conductor. Very nice, you guys are great. So what I'm going to do is, and you can do this along with me, I'm going to take my Epsom salt, I'm going to open up my little bag, and I'm going to pour it into my water. All right, I poured it all into my water. And then I'm going to take my craft stick, my little popsicle stick, and I'm going to start stirring. And if you're doing this along with me, wherever you are, go ahead and start stirring too, because we want these crystals to dissolve. We want to make some nice Epsom salty water. So just keep stirring until we can't see them anymore. I see a comment in the chat. My friend was saying that the batteries can heat up. That is true. And that's another great point in battery safety. We want to make sure that we are not touching our battery unless it is in use. And I'll tell you about kind of the particular ways we're going to touch our battery when we're using them. And mine's looking pretty good. It's a little bit cloudier than it was before. That's because it's got a bunch of salts in it now. But I can't really see many individual crystals. So I want you to stir yours until it looks kind of like that. So right now, our salty water is a good electrolyte. This is something that electricity can pass through and potentially get to something like from a power source to something like a light. But there's other things that electricity can pass through besides our salty water, though we are going to be using that. I made sure that you guys had some pencils in your kit. Now, what is a pencil made out of? What is a pencil made out of? I know we had a friend who said earlier that wood is not something that conducts electricity very well, right? There's a bunch of wood in there. That probably won't help electricity move through something like a pencil, but it has another part. My friends are saying that a pencil has a lead, and even though it's called lead, it's made out of graphite. And I'm going to ask my friend Caroline to put that in the chat. This part right here, though we call it the lead of the pencil, it's made out of graphite, which is basically just a chemical called carbon. So this graphite is something that works really well for passing electricity back and forth. This graphite will work almost like a wire to move electricity. I had a friend in the chat whose wonderful scientific mind was wondering what this might taste like. The answer is we don't want to taste it because we need to use this for our experiment. But if you were to taste it, it would just kind of taste like salt. Epsom salts are not really like toxic if we're consuming this amount of them, but you don't really want to. It's not going to taste great. It's going to taste like salty water. So we're saying that part of our pencil, this graphite in here, can conduct electricity. It lets the electricity move. What we're going to do is we're going to use our pencil sharpener to put a point on both ends of the pencil. So I want you to use your pencil sharpener to make a two-ended pencil. And I'm going to do this one with you all. So I've got this end of the pencil. This one's already sharp. I don't have to touch it. But I can use my pencil sharpener to sharpen my pencil. I'm just twisting it like this. So it didn't take me very long to get a nice sharp point. Ooh, that's pretty sharp. So we want to be careful around those points. But we have 2 points to our pencil now. I'd like you to do that to both of your pencils. So we have 2 pencils that each have 2 ends. I will tell you a little bit more about battery safety, right, while we are sharpening our pencils to make them 2-headed pencils. We talked about how you don't want to touch your LED to this battery. I also wanted to explain kind of how this battery is shaped, right? Here's a battery that I'm more used to, right? Like a AAA or a AA battery is something that I use a little bit more often. And I know that it has a positive side and a negative side. This battery does not have 2 ends like that. It has its positive and negative end up here. So one is the positive and one is the negative. So this is the positive end, this is the negative end. That means if we do something to connect those ends, we will be starting to pass electricity through. So that's something that we don't really want to do. You don't want to leave this face down on some tin foil, for example, just because it will heat up the battery, and we want to make sure that our battery is not heated up. We're going to be using our clips later to connect some different things. We never want to connect our battery to itself. We don't want to do that. That will ruin our battery. It's potentially dangerous. Yeah, we won't be able to do the experiment because it'll ruin our battery. Okay. We want to make sure we have our two-headed pencils. Now, we said these pencils are going to act a little bit like wires. We have wires here. We're going to be using both wires and our pencils to move electricity around. Once you do have your two-headed pencils, I'm going to have you do something that I need to switch to experiment cam for to show you better. I'm going to switch over to experiment cam. We've got our mixed up electrolyte solution here. I've got my two-headed pencils, and now I have my little piece of foam. What I want to ask you guys to do is we're going to poke our pencils through this foam. So I'm going to do that kind of carefully. So I poked it through. You can see it didn't go right through yet. I'm going to start to poke it, and really gently I'm just pushing and twisting. Super gently. And I want to make sure that they're pretty close together. This is where I'm going to put the other one. So you can see they're not very far apart at all. Gently pushing, whoop, there we go. Gently pushed my pencil through. So there's one pencil. And now I want to push my other pencil through it. So right now we've got an interesting construction that looks like this. We've got our two pencils that have a point on each end, and they're sticking through our piece of styrofoam like this. Now the first thing that we're going to do is prove that electricity can move through our graphite leads. And to do that, we're going to need our wires. Put this stuff all out of the way here. We're going to need our wires to connect to here. So you should have two different color wires. I'd love to hear what colors you have. I have one black wire and one red wire. I know there were a bunch of different wires that I packed into your kits, but we should have one of each color, and that's great because it'll help us make sure that we're not confused about it, about which one goes where. Oh, sounds like one of our friends has one black and one white. Oh, we have one friend who has yellow and green. Oh, that's great, you guys. So we have some different colors of wire. Oh, black and yellow, perfect. I want you to take the color of one wire, and I want you to practice using it as a little crab claw, and you do that by squeezing this part right here. Squeeze it, and it's like a little crab claw. I want you to take that little claw, and I want you to attach it to one end of your battery. So I'm going to do it like this, and attach it to my battery there. You can see that it's hanging on to the edge of the battery. There we go. Like that. My other end of my wire is not touching anything right now, but one end is stuck to my battery. What do you think we're going to do with the next one? We're going to do the exact same thing, just on the other end. So take your other color of wire and clip it onto the other end of your battery. So we should have our two colors of wire. One of them is attached to one part of the battery, and one of them is attached to the other part. So now what should happen is the electricity can move through the wire, and if we touch this to something electric, the electricity should be able to go through it. But I want to tell you guys, we do not want to connect it to our LED yet. I tested this out and the current was still too strong. It still burnt out my LED, so don't connect it yet. We're going to connect these wires to something else. We're going to connect them to an end of our pencil. So go ahead and take one of your wires, and I want you to connect it to crab claw it right onto one of your pencil leads, onto that graphite there, just like that. I'll get it a little bit closer. So we want it to be really securely right onto that pencil lead like that. And then we want to do the same thing with the other end. Just kind of snipped right on like that. And I'll tell you, it can be sideways, like this. You can do it straight up and down if that works better for you, just as long as it's touching, as long as it's squeezing onto the gray part, the graphite, and not really touching the wood, because as my friend said earlier, wood is not a very good conductor of electricity. So now we've got a very strange looking contraption here. We've got our battery, we've got our wires clipped onto our battery, and then we've got our wires clipped onto the points of our pencil. What we're going to do is see if our pencils will conduct that electricity. Will they let the electricity move all the way through and into our LED? We are going to find out. Experimenting is sometimes the only way that we can find out. Now, before we do that, I just want to let you guys know that LEDs are polar. That means that they only work in one direction. So if I connect it one direction, it doesn't work, but if I flip it around, it does. So if you put yours on and it doesn't work, try just flipping it around to the other side and seeing if it works. With that in mind, we're going to see if our LED will light up if we connect it. Whoops, keep knocking my battery over. If I connect it to the two ends of my pencil. In order to have it connect, right, these two little metal legs onto each graphite lead, I'm going to very gently kind of stretch them apart like that. And I'm going to see if this will work. I'm going to try and connect them both. I'm going to try and bend it here, right? Instead of up here, I'm going to bend it down there if I need to. That way it doesn't accidentally get disconnected. Okay, so I'm going to see if mine works. You should test yours and see if it works. All right, this, let's see if the camera can pick it up. Go ahead and test that out and tell me what you're seeing, my friends. Let's see. Oh, this one doesn't want to work very well. Let's try flipping it around. What about you, my friends? How's yours going? Oh, 3 friends in the chat that it's working out for them. That's good because I'm having to try something else with mine. I'm going to see if this will work better. So we have a couple friends for whom it is working. That's perfect. Oh man, I can't get mine to go. And if you're like me and you can't get yours to work, so what I'm going to do is I'm going to check my different contacts. I'm going to make sure, is it well attached here? Is it well attached here? Oh, my black wire came off. Okay, well that broke the flow. Let's see if I can attach that again. Let's see if now it will work. Probably has a better chance of working when everything's connected. Oh, that sounds awesome. It sounds like a lot of friends are having some success, which is awesome. Oh, there we go. Okay, finally I got mine to work. I checked all of my connections and found that I can get it to line up. So that's okay. And if we can't get ours to work completely, that's okay because we can keep trying. But as long as we make sure everything is connected, we should be able to create our light. You saw how many times that I had to try it again to make sure that it worked. You saw that mine didn't exactly work, so you just have to keep trying. So mine finally started working here. I know that the electricity is moving through the lead of these pencils, And I want to do one more thing with electrical current today. We know that it can light up a light. And we're going to let that electrical current do something else. So we had, at the very beginning, we had you guys mix up some water and Epsom salt. Do you guys remember, did we say that electricity could move through this liquid? What do you think? Can electricity move through this salty water? We talked about it way back in the beginning about electrolytes. Is some friends saying yeah, some friends saying maybe. I have a friend saying maybe not very well. No, it's true. Maybe it won't move through this as well as it moves through something like pencil lead or through a wire. But since we added our salt to this water, it should be able to conduct electricity. It should allow electricity to flow. We're going to test and see if it can. So what we are going to do is we're going to take our kind of construction here, right? Our battery is attached with our wires. Our wires are also attached to our pencil lead. It's okay if your battery doesn't stand up. Mine doesn't want to stand up either. And what I want you to do very carefully is to tip it up like this. And I want you to lower it into your water. We want these pencils to go all the way into the water. And we want to make sure that as best as we can, they're not touching the bottom and they're not touching the sides. So in just a second, we're going to do that. And I'll let you know now, the reaction that takes place is not instant. So we're not going to immediately see something happen, but that is okay. We're going to use our powers of observation. So we have our pencils here, and we're going to dunk them in our water. Whoops. And we're going to do our best to keep our clips on, like this. So if you're like me, you just dunked yours in, and you're not noticing anything very different yet. Because I want to have you keep your eyes on that gray graphite, that pencil lead. And I want you to tell me if you see anything. Or if you're just watching along, do you see it on mine? Ooh, I have a friend who's beginning to see some bubbles. I am too. I'm beginning to see, especially on this side, some bubbles. And yeah, you're right. I do see a few on the side here. Now I want to make sure that these bubbles aren't coming from somewhere random, right? So I'm going to make sure, I'm going to tap this down like this to make sure that there's no bubbles here. I'm going to look at my pencil lead like that. And I'm going to dip them in again. Oh, I even see some of my bubbles bubbling up. So it sounds like a couple of my friends are seeing some bubbles on the sides of their pencil, or on the leads of their pencils. What are those bubbles? Where are they coming from? Any ideas? Where on earth are those bubbles coming from? How come we're creating bubbles in our water? This isn't seltzer water. Where do those bubbles come from? I have some really good thoughts in the chat. I have some friends who are thinking about their hypotheses, their scientific guesses are, wait a minute, are the bubbles coming from the salt? Could it be from the salt? Could it be from, is there air in the pencils? Now that is a very good thought. Could it be the pencils? I have a friend who's saying that they're noticing maybe some movement in the water. That's interesting. That's very interesting. Now, I also was wondering, okay, hold on a second. Could it be bubbles from just the pencil, right? There's wood, maybe there's some air bubbles in the wood. But if I were to do this same experiment, I'm going to take these off for a second. If I do this same experiment with a regular pencil, it's not connected to anything, like that, I can leave this in here for a long time and I won't see any bubbles. So that was a very good thought. Maybe it was from the air in the wood, but if I leave this in here, I will not see any bubbles begin to form. It's something else. We're doing something called electrolysis. I'll have you see if you can see any of those bubbles form again. This is called electrolysis. Oh, and I have some friends who are guessing, yeah, maybe those bubbles are coming from something to do with the electrons. What it's doing is electrolysis is when you run an electrical current through something and it starts to take it apart. What's happening with our pencils is they're beginning to take the water molecules apart. Does anyone happen to know what the scientific name of water is? What the chemical formula for water is? Oh, I have a friend who knew it right away. H2O. That means there's some hydrogen atoms in there and there's an oxygen atom in there. H2O. So it's kind of like our Lego that we were talking about before. Instead of these being particles, we're going to say that these are atoms. So here's my hydrogens. I'm going to connect them to my oxygen, and then I've got a water molecule. What my electrical current is doing is it's breaking them apart into just oxygen and just hydrogen. And those hydrogens and oxygens are gases, and we're seeing those gases in the form of bubbles. So our water molecules that are made up of hydrogen and oxygen, the electrical current is breaking them apart. And our different pencils have different gases coming out of them. So the negative pencil, the pencil that's coming out of the negative side of the battery, that one is the one that has our hydrogen, which has to do with the charge of the hydrogen atom. Let's see, I'm going to find my negative end. For me, that's the red wire. That red wire is connected to, I'm going to move this so you can see my bubbles there. That's connected to this pencil, which would be called a cathode in this experiment. This is my cathode. And these bubbles are where the hydrogen is coming out of. I'm also noticing that there's more bubbles coming out of that side than the other side. And that's because there's a higher hydrogen content in a water molecule than an oxygen content. So I am creating oxygen, but there's less oxygen than hydrogen, right? So the oxygen is coming out of my positive side. This is my anode, my cathode and my anode. My cathode is the negatively charged one that's producing hydrogen, and my anode is the positively charged end that is creating oxygen. So this is a really amazing experiment to me. It's kind of weirdly simple. All we're using is pencils and wires and a battery and some salty water, but we're splitting a molecule apart into its different pieces. We can even see, because one of them has more bubbles than the other, we can even see that there is a higher hydrogen content than there is oxygen content, because there's more and bigger bubbles. One of the reactions I'll say, if you ever decide to do this again, because you can do it again with these supplies, is you want to make sure that you're not using table salt. So we used a special salt called Epsom salt. Table salt, regular table salt that you use is NaCl, which is sodium chloride. Sodium chloride plus our electrical current will create chlorine gas, and chlorine gas is not something that we want to breathe. It's something that can make us sick. So by using Epsom salts, you're not creating any harmful gases as a result of this experiment. But it's something that you can continue to do at home if you want to. You can experiment with different amounts of Epsom salt in here. You can experiment with different amounts of water. You can try to see if you have any other materials that also conduct electricity besides pencils, right? Because you don't have to use pencils. You could use anything else that will pass electricity through it. And your 9-volt battery should last fairly long as we don't leave it connected to something for too long. So what do you think, my friends? We just did a really interesting experiment. We not only proved that we can use pencils to conduct electricity, we saw a way that we can separate the molecules of water in an electrolyte, in a conductive liquid. I wanted to ask if you guys had any other questions. I see one in the chat, which is, what is the voltage rating of the LED? That is a really great question. I know I often use a coin battery with them, and these are 3 volt. So the 9 volts would be too much voltage, and it will. I can even show you, now that I finished my experiment, I'll even show you that it will short out our LED. Yeah, my LED that worked a second ago, oh, it had a little flash and then it will no longer work. So we don't want to short out our LED. This one now will no longer work even if I use the proper battery for it. Yep, busted because there was just too much voltage in that 9 volt. I have another question saying, if we put the metal prongs from the LED in the water, will it light up? Ooh, and a question of, is it dangerous? First of all, always good to ask if something is safe before we're going to be doing it. So if we have our pencil that's attached to our battery and we stick our LED in there, I don't know if it will light up. I'm not sure if the current is strong enough to light it up. If you do want to try it, I think it is safe as long as we're not dipping our fingers in the water, right? The voltage that's going through, there's not anything that's going to shock us, but just in case, we want to make sure that we are not coming into contact with this water. We don't really want to touch the water. Very nice, my friends. Any more last questions or thoughts or ideas before we say goodbye today? I really, really appreciated the opportunity to give you guys some science supplies that you can continue to experiment with and doing a really amazing experiment. Thank you all so, so much. We're hoping to keep doing labs at your library in the future, so keep an eye on your library's like Facebook event page. So make sure and check those out. We're going to have a new experiment in the coming months. I really hope that I'll be able to see all of you guys there. I hope that you have a great rest of your day and a great weekend, a great Memorial weekend, in fact. All right. I'll see you guys later. So long. Thanks so much, friends.